Hello and welcome. In this presentation, students, or you in particular, are going to learn how to calculate the unknown length of a side in a right-angled triangle using either the sine, cosine, or tangent function. Now, just as a recap from some of the previous sessions, we've looked at naming the sides in a right-angled triangle. They are either the hypotenuse, the side across from our right angle, the opposite, the side that is across from our reference angle or adjacent, which is the side between reference angle and right angle. We've also defined the trig ratios. Sine theta equals opposite, or the length of the opposite divided by the length of the hypotenuse. Cosine, which is equal to adjacent divided by hypotenuse. And tan, which is equal to opposite divided by adjacent. Two other items that you need to be aware of when using algebra and solving these types of problems. You'll have to solve a little bit of algebra. So the first type of equation you need to be comfortable solving is 15 equals some number which is x divided by 2. To solve this, what I want to do is apply the inverse operation to dividing by 2, which is multiplying by 2. So effectively I'll multiply both sides by 2, and that will give me x equals 30, or you need to be comfortable solving this sort of equation where you have the x as the denominator in the fraction. This situation, you flip the x and the 16, well, you swap them across. Just move them from one across to the other. So you end up with x equals 2 divided by 16. So just be aware of those two, because I'll just be jumping through those fairly quickly in the presentation. Now, the steps that you need to follow to solve problems which involve a right angle triangle. There's my right angle, and I have an angle, one side length, and an unknown side length. You've not already done so, draw a picture of the triangle. Now the next thing you need to do, step 2, identify the knowns and the length to calculate. Well, my knowns are 30 degrees, 5, calculating x. Now I need to name the sides of the triangle. So this side here, well, that side is the hypotenuse across from the right angle. This side here is my opposite across from my reference angle. I don't even need to worry about that side there. It's not adding any value. Now I need to identify the trig ratio to use. Now here are my trig ratios. Which one of those contains both the opposite and the hypotenuse? Well, you can see it's the one right at the top. It's the sine theta. So identify the trig ratio to use. Sine theta equals opposite divided by hypotenuse. I always write that down. And then the next thing I do is I populate this ratio with the values of my knowns and unknowns. So my angle theta is 30. My hypotenuse is equal to 5. See, that's there. And my opposite is the x. Then I just need to rearrange this equation using my algebra and use my calculators to solve for the unknown. So you'll see here, x equals 5 multiplied by the sine of 30. It equals 2.5. Now I should just show you how to do that on the calculator. So this is my calculator that I use. I just basically want to multiply 5, and I want to multiply that by the sine of 30 degrees. There you go. And you can see there that equals 2.5. If you don't get 2.5, just verify in the settings on your calculator that it has been set up to degrees. Okay, next problem. This time, we'll just follow those same 6 steps. Here is my right angle triangle. Identify the knowns and the unknowns. Well, here is a known, side length of 5. Here is a known, angle of 35 degrees. Here is an unknown, length of x. Now let's name these sides. Well, that one again is the hypotenuse. Now this one here, it is, just thinking about that, it is the adjacent. It's because it's between my reference angle and my right angle. Don't worry about this side here. Now, look to identify which trig ratio contains adjacent and hypotenuse. And there you go there. Adjacent divided by hypotenuse is cos theta. So, we know our trig ratio, and then I just populate the values of knowns and unknowns into that trig ratio. So, cos of 35, that's my angle, equals the length of my adjacent, which is x, divided by 5. Then I'll rearrange that equation and solve that using my calculator. So that's how you would do it manually, and on your calculator. 5 multiplied by the cos or the cosine of 35 degrees. So there you go, 4.0957. I've just rounded that up to 4.1. And we'll just move on to the very last example that I'll be going through. So again, the same 6 steps. I have my right angle triangle. Identify the knowns and the unknowns. So I look at my triangle. What information do I have? Well, I have an angle of 40 degrees. An unknown length here of x. An unknown, well, a length here of 5. Right, I'll name the sides of the triangle. So I'll name this side here, the one with the x. There you go, that's the adjacent. I'll name this side here, the 5. That's the opposite. I don't need to bother about this side here. There's no information in there that's useful. Now, what ratio do I use? What is the one that contains the opposite and the adjacent? Well, you can see here that tan theta equals opposite divided by adjacent. So, I write down that formula, the ratio. Then I put into that formula the values of my knowns and unknowns. So tan of my angle equals the value of my opposite divided by the value of my adjacent. Now, this time, notice I have the x down the bottom, so I'll actually, in the next step, be swapping these around when I go to solve that. So use algebra and a calculator to solve for the unknown. So there you go. I have swapped the x and the tan of 40 around, and then I put the numbers in my calculator to get 5.96. We'll just show you how I could do that. 5 divided by the tan of 40 degrees. There's your answer there, 5.958, and I've rounded that up to 5.96. So there you go. There are 3 examples demonstrating how to find an unknown length in a right angle triangle when one side and one angle have been provided. I hope this presentation has been of assistance. So until next time, good maths.